Anthropic may be preparing for one of the biggest changes in Claude's history, and it has almost nothing to do with making a chatbot answer questions better. The company is reportedly in talks to acquire Decart AI in a deal that could be worth around $6 billion. Decart is not another chatbot company. It builds AI systems that generate and transform visual worlds in real time. Its Lucy models can modify live video while it is happening. Its Oasis system generates interactive simulated environments where autonomous vehicles and eventually robots can move, react, fail, and learn. If Anthropic actually buys Decart, Claude could begin moving beyond language, coding, and digital agents toward AI that understands changing visual environments and interacts with simulated versions of the physical world. But there is another reason this deal could matter even more. Decart has spent years trying to make extremely demanding AI models run fast enough for real-time interaction. And Anthropic is now facing the same problem at enormous scale. Claude is becoming an agent. An agent does not generate one answer and stop. It may read hundreds of files, execute code, browse information, call tools, evaluate results, retry failed approaches, and operate for minutes or hours. Every action requires more inference. That means Anthropic's future may depend not only on building smarter models, but on making intelligence dramatically faster and cheaper. Decart could help with both. Start with Lucy. Traditional generative video works almost like rendering a movie. You give the model a prompt, wait while it calculates the result, and eventually receive a clip. That is useful for content creation, but it is not interactive. If a model needs several seconds or minutes to generate what happens next, it cannot become part of a live environment. Lucy approaches the problem differently. Decart describes Lucy as a real-time video and world editing model capable of transforming people, objects, environments, and visual effects while video is being created or streamed. Its latest systems operate at interactive speeds. Imagine pointing a camera at yourself and telling the AI to change your shirt, alter the background, add an object, or transform the visual style while you are still moving. The generated world changes with you. That may initially sound like a streaming or entertainment technology, but real-time generation becomes much more important when AI begins interacting with the physical world. A robot cannot wait 30 seconds to imagine what might happen if it turns left. An autonomous car cannot pause reality while a model generates the next scene. Physical intelligence needs models that respond at approximately the speed of the environment itself. That is where Decart's second major technology becomes interesting. Oasis 3 is what Decart calls an interactive world model for physical AI. Instead of generating a finished video, Oasis generates an environment that changes according to actions. A user can describe a road, weather, lighting, geography, or traffic situation. Then an autonomous agent can send steering and throttle commands. The model generates what should happen next. Actions go in. The next version of the world comes out. And this process continues in real time. This turns generative AI into something closer to a simulator. Why would Anthropic care about that? Because simulation could become one of the foundations of physical AI. Training robots in the real world is painfully slow. Imagine teaching an autonomous vehicle what to do when a truck loses cargo during heavy rain at night while another vehicle suddenly changes lanes. You cannot easily create that situation thousands of times on a public road. The event is rare. Reproducing it intentionally may be dangerous. Collecting enough examples could take years. A world model can theoretically generate variations of the scenario continuously. Change the road, change the weather, move the vehicles, alter visibility. Repeat the failure, then let the autonomous system practice again. Decart says Oasis 3 is initially focused on autonomous driving but is designed to extend to drones, off-road vehicles, maritime systems, and humanoid manipulation. This does not mean Anthropic is suddenly becoming a robot manufacturer. There is no evidence that the company plans to build a Claude humanoid. The more interesting possibility is that Claude could eventually become the reasoning layer above systems that operate inside these environments. Consider a future warehouse robot. A high-level Claude model could receive an instruction such as find the damaged package, move it away from the conveyor, and inspect the surrounding area. Claude handles the goal. A perception model understands the visual scene. A world model predicts possible consequences. A specialized control system moves the robot. The entire system continuously observes what happens and replans. Language models and world models solve different parts of intelligence. Large language models are extremely good at relationships between symbols, concepts, instructions, and knowledge. World models are trying to learn relationships between actions and changing environments. If I move this object, what happens next? If a vehicle turns here, where will it appear? If a robot pushes a box from this angle, will it slide, rotate, or fall? Intelligence in the physical world requires both. This makes Decart strategically interesting to a company whose strongest technology currently lives mainly inside language and software. But the acquisition talks may have a more immediate explanation: performance. Decart describes its infrastructure layer, called DOS, as an optimized system for AI training and inference. The company says the same infrastructure powers Lucy and Oasis and is designed to make AI models operate with extremely low latency. Anthropic needs exactly that type of optimization. Claude's growth is creating enormous infrastructure requirements. The company has already committed to massive computing arrangements involving Amazon, Google, Nvidia, and AMD. It is also building an internal chip design team. All of these moves point toward the same constraint. Inference is becoming expensive. Imagine an ordinary chatbot conversation. You ask 10 questions. The model answers 10 times. Now imagine Claude acting as an autonomous coding agent. It reads a file. That is one operation. It searches another file. Another operation. It writes code, runs tests, reads the error, changes the code, runs the tests again, searches documentation, creates another sub-agent, verifies the final result. A single user request can trigger dozens or hundreds of model interactions. Agents multiply inference, and when millions of customers use agents simultaneously, small improvements in efficiency become enormous financial advantages. A 10% reduction in inference cost at small scale is interesting. At hyperscale, it can be worth billions. This may explain why Reuters reported that, if completed, Decart's team would join Anthropic's inference and performance organization. That detail is important. It suggests Anthropic may value Decart not simply for flashy video models, but for the engineering required to make complex generative systems respond in real time. The acquisition would also continue a broader transformation inside Anthropic. Claude began as a conversational AI, then Claude became a coding model. Then Anthropic pushed toward agents. Now the company is investing deeper into infrastructure, custom silicon, and potentially real-time generative systems. The direction is clear. AI companies are becoming full-stack technology companies. Building a powerful model is no longer enough. You need chips, inference software, cloud infrastructure, agent frameworks, security systems, multimodal perception, and eventually models capable of understanding dynamic environments. Google already has many of these layers. Gemini is connected to search, Android, cloud, robotics research, custom TPUs, and world model work. Meta is combining AI models with enormous consumer distribution and increasingly specialized infrastructure. Nvidia is building not only chips but robotics models, simulation systems, networking, and complete AI platforms. OpenAI is expanding toward agents, hardware, and infrastructure. Anthropic cannot remain only the company that makes Claude. The competitive battlefield is getting larger. A possible $6 billion price for Decart also reveals how valuable this new layer has become. Decart was founded only a few years ago, yet the startup has developed a combination of real-time generation, world models, and inference optimization that could make it strategically important to one of the largest AI laboratories in the world. But the deal is far from certain. Reuters says discussions remain at an early stage. Anthropic could walk away, the reported valuation could change, and even if the acquisition happens, integrating the technologies would take time. World models also remain imperfect. A generated environment can look convincing while behaving incorrectly. A simulated vehicle may move realistically most of the time but fail to reproduce an unusual physical interaction. That matters enormously when simulation is used to train machines that later operate in reality. A video generator only needs to fool the eye. A physical world model eventually needs to approximate cause and effect. That is a much higher standard. If the simulated world teaches the wrong physics, the robot can learn the wrong behavior. This creates what could become one of the biggest challenges in embodied AI. How realistic does a simulated world need to be before experience learned inside it transfers reliably to reality? No company has completely solved that problem, but the economic incentive is enormous. Real-world data is expensive. Simulation can theoretically generate unlimited training experience, and AI itself is making those simulations increasingly realistic. That creates a feedback loop. Better world models create better simulations. Better simulations produce more training data. Better training creates more capable agents. Those agents generate new information that improves the world models again. Anthropic may be looking at Decart and seeing more than another startup. It may be seeing infrastructure for a future where Claude no longer interacts only with text, code, and websites. Claude could eventually reason about environments that continuously change in response to actions. And even before that future arrives, the same technology could help Anthropic solve a much more immediate problem, making increasingly complex AI run fast enough and cheaply enough to serve millions of agents. That is why this potential acquisition matters. The next AI race is not simply about who produces the smartest answer. It is about who can build systems that perceive, predict, act, and respond at the speed of reality. Anthropic built Claude to reason about information. Buying Decart could be a step toward teaching that intelligence to reason about worlds.